What's the word inequality mean? Huh? Equality means what?
Equal.
Equal. Two things the same. So inequality means that they are
Not equal, like different.
not equal. They're different. Okay. Every time that we deal with inequalities throughout math class, whether it be geometry or algebra 2 or pre-calculus or trig or whatever, we're going to deal with equalities. Okay. And once we are comfortable with equations and solving those equations, the next thing that they always ask us, okay, where are things unequal? Or what are relationships that exist when things are unequal? Well, what's really nice is that we know a lot of stuff about equations and equality. If I know where things are equal, I should automatically know where things are unequal. Does that kind of make sense? Okay. And we can use some of those properties maybe with the things that we do today. But an inequality is simply saying that things are not equal. Okay. But our interest is going to be not necessarily just where they're unequal, but how are they unequal? Which one's bigger, which one's smaller? All right, so this is a concept that you guys are pretty familiar with. I'm really not going to worry about saying that, B could be any number here and only forcing C to be greater than 0. Let's just worry right now about B and C being positive numbers. If B and C are positive numbers, okay, just take two numbers down together, okay? You get a sum of A, right? So I take 2 and 3, add it together, I get 5, correct? What this property is saying is that when you get that 5, you can compare it to the things that you use to add together, okay? The components that you sum together, the 2 and the 3. And can you always say that 5 is bigger than 2? And say that 5 is bigger than 3? All right? That's what this is getting at, okay? Now, you can't always do that with addition because let's say that my two numbers I'm adding together are 10 and negative 12. When I do that, I get negative 2 back, right? Okay? Is negative 2 bigger than 10?
No.
No. Okay? So with negative components, that's why they say C's got to be bigger than 0. With negative components, that doesn't work. Okay? But I can do it with just positive values. And that's really what I want to work on and look at because what we're interested right now is dealing with just sides and angles of triangles, and they always have to be what kind of numbers?
Even.
Not even.
I mean positive.
Positive. Okay. So you guys remember from chapter 4 when we had an exterior angle of a triangle. Okay. So here the exterior angle is angle 1. You remember the names of a vocabulary word that we use for angles 2 and 3?
They're the same side.
Are they close to 2, or are those angles close to angle 1?
Well, they equal 180.
The remote interiors. Okay. The 2 and 3 don't add up to 180 because then I won't have any leftover room for the remaining angle.
Oh, that's not what I meant. I meant the line.
Okay. So angle 1 is an exterior angle, and then based off of knowing that angle 1 is exterior, angle 2 and 3 we can classify as remote interior, right? Okay. Basically using this theorem, this geometry concept, and the property that we just talked about, the algebraic property we just talked about, if I'm taking 2 plus 3 to get 1, doesn't that mean that angle 1 is going to be bigger than either angle 2 by itself or angle 3 by itself?
Yeah.
Does that make sense? Is that pretty easy, almost an elementary concept?
What did you say?
Okay. If I look at angle 1, give me a measurement for angle 1.
10,000.
Let's go a little bit bigger.
100.
Okay, 100 is fine. So if that's 100 degrees, we had a theorem in chapter 4 that said angle 2 and angle 3 have to add up to 100, right?
Yeah.
So give me an angle for number 2. Give me a number.
99.
Give me something different.
25.
25. Okay, so that's 25. This would be
75.
75. This theorem is simply saying that 100, angle 1, is that not bigger than 25?
It is.
Yeah. Is angle 1 bigger than 75?
Oh, it is.
Yeah. So what they're saying here is with an exterior angle, it is always greater than either of the two remote interior angles. Because you got to add the two interior angles up to get the exterior one, right?
Yeah. So if it's like 2 was 100, then 3 would have to be 0, and that's possible.
Okay. Yes. Yes. Okay. Is that pretty straightforward?
Yeah.
All right. Huh? That work?
Yeah.
The
Your mouse is in
The other theorem that we talked about is actually two more. One of them you already know. If you remember back to chapter 4, when we first started chapter 4, if I gave you all three angle measurements of a triangle, would you, without knowing any side length measurements, would you be able to order those side lengths from smallest to greatest? If you knew all three angle measurements.
Yeah.
Okay? And vice versa. If I gave you all three side lengths, could you tell me the angle measurements from least to greatest?
Yeah.
Okay, so this is that. Those are inequalities of one triangle. If I'm dealing with these two things right here, look at those two angles. Which one is bigger?
C.
Angle C, right? The green one. So don't we know then, even though I don't know any measurements, don't we know that this side here, that green side, is going to be what in comparison to that red side?
Bigger.
Yeah, the green side is bigger because the angle across from the green side is bigger than the angle across from the
Red line.
red side, right? Is that doable?
Yeah.
And then vice versa, it is maintained as well when maybe I don't know these two angles, maybe they're hidden from me. But we know those distances. Okay, I'll change the angles. So if I look at those two,
Wait, but what if like you move it to where A is bigger? And does it just change it?
right, so if A ends up being, so right now you're telling me that the green angle is bigger, right?
Yeah.
Because it's across from 6.53?
Yeah.
So you want me to change this so this angle here is bigger?
Yeah. You know, change of that angle is smaller. Wait, the green line's smaller than the red line's bigger. Yeah.
Okay, so now
The
the
whole thing?
so the green line now is smaller than the red line, correct?
Yeah.
So what's that tell me about the red angle compared to the green angle?
That angle is bigger.
Yeah, this angle is bigger. And then we can, put those in, and we see the red angle is 105, and the green one's 37, right? And it does make sense then that that exists. So, those are inequalities. And what we're saying is that how the angles are unequal, then the sides are unequal in the same fashion. Okay? If the red angle is bigger than the green angle, then the red side is bigger than the green side. Does that make sense? Okay? And that's just consistent for all triangles. Is that doable? Pretty easy? All right. Hopefully that's not new information to us. Hopefully that's something that we remember from the last chapter.
It's not.
If I were to give you, and this is the last theorem, this is the one that's kind of the most important for this section. If I were to give you just random segments of any length, okay, 3 of them, okay, and I tell you create a triangle with those 3 segments.
They'd all be the same.
Hold on. But you've got to put your side lengths, you have to put your sides end to end, okay? Meaning that there can't be any kind of leftover excess overhang with my segments. Does that make sense? So you can't do, like if I give you 3 segments and ask you to make a triangle, you can't make a triangle kind of that way, right? Does that make sense?
Yeah.
Okay, that is a triangle. We do create a triangle inside there, but it's not using the entire lengths that I provided you. Okay, we want to go end to end. There has to be some type of relationship between the 3 segments that I give you so that that is possible. Okay? Hold on a second. If I were to give you segments of 8, 1, and 4, can you
No, it's impossible.
make a triangle? If I start rotating that around, I'm going to keep 8 static. Rotate those around, either the blue segment or the green segment. Will I ever be able to get those yellow dots to touch to create the 3rd
Blue one
vertex?
has to equal 4.
Say it again.
Blue one has to equal 4.
Okay, close. So you're saying, so right now they don't create a triangle, right? So you're saying take the blue one and make it go to 4.
Yeah.
Okay? Now if I make it go to 4, what's going to happen is you're going to get them to, those points intersect right there. Does that give me a triangle?
I know it has to be either the same or more than.
Okay, it's got to be more than. Okay? So we want to be greater than 4. And the idea here, see if I can come in here and do this.
Wait, they won't go up at all?
No, if they're the same, if these 2 segments are the same, then that point is going to be on the red segment. But once I make it a little bit bigger, let's make one of them 5.
Yeah.
Now it will go up, right?
Yeah.
And now they will eventually, if I can manipulate it, this one.
We know what you mean.
Yeah, it's supposed to be, I made it nice and, come on. Well, whatever. When it works, it turns that triangle solid yellow, and it gives you a, you made a triangle kind of statement. But if I look at those, okay, the relation between those, what is the relation between the blue side and the green side compared to the red one?
Like the blue and the green one have to add up to be more than 8
Good.
on the red line.
Good. So the two smaller sides, in order for you to get a triangle to exist, the smallest two segments that you are provided have to add up to more than the third side. Okay? Now that being said, is 5 and 4 are not the first two segments that would happen with. Think if I had a segment of 4, and then I had a segment of 4.00000, however many zeros you want, in a 1. When I add those together, is that bigger than 8?
Yeah.
Yeah. Except for that triangle is going to be a very, very, very...
Close triangle to read.
Yeah, it's going to be a very, like... compressed or shortened. I actually put the point on that line. I didn't want to do that. So let me zoom in real quick to kind of show you the concept here.
Can't you just type that in?
Yeah, I could. So I put a point right there. Okay. And then I ask it for a segment. Would you guys agree at that point is not on that line?
Yeah.
But if I put J to
It's
H,
gonna look like it is.
yeah, J to H and J to I,
You didn't make it to H.
and we zoom back out, that looks like a line, right?
Yeah.
But when we zoom in, we do see that is a triangle.
Yeah.
It's just a very, very, very compressed triangle. So the thing is that these values, 5 and 4, their sum has to be just a little bit bigger than 8, okay? Just greater than 8, okay? So if they're both equal to 8, if I add 5 and 4 together, then this side could not be 9, for instance. Because if I get 9, let's say we let that third side be 9, then we're back to the idea of basically calling this maybe a collapsed triangle, where that third vertex doesn't exist.
Look, you did it.
Okay? So the theorem that we're interested in order for you to create a triangle with 3 segments, is that any 2 segments added together should be bigger than the third segment.
Greater than.
Okay? Yes. So any 2 segments should be larger than the third one. So let's say that we go back to this. Would you guys agree that to get the triangle, there we go, to get our triangle, 5 plus 4, is that greater than 7?
Yeah.
Is 5 plus 7 greater than 4?
Yeah.
Is 4 plus 7 greater than 5?
Yeah.
Yes, okay? All 3 of those conditions have to exist for you to be able to create a triangle, okay? But we're lazy and we don't like to have to check all 3 of those conditions. So, using a little bit of algebra concepts, okay? If I know that 5 and 4 are the smallest sides, right? And I add those together, okay? 5 plus 4 is greater than 7. Would you agree with that? Okay. Well, now let's say that instead of 5 and 4, we're gonna make this number here go up to the 7. And I'm adding 5 then, right? Well, the only thing that could be over here then is this number going down. Does that make sense? So on the sum side, I made a number go up, and on the total side, I made a number go down. Well, doesn't that mean that that is going to have to be true regardless?
Yeah.
Okay, so in the event of checking to see if we can make a triangle with 3 segments, all we have to ever do is check the smallest 2. Find your smallest 2, add them together. If it's bigger than the third one, then all 3 conditions will hold. Okay? So you're going to see some questions in your homework that simply ask that. They're going to be kind of like this, where they say, Here are three segments, 4, 8, and 11. Do those create a triangle? What are the smallest two? 4 and 8, right? Add those together. Does that give me something bigger than the third side? Is 12 bigger than 11?
Yeah.
Yeah. So does that give me a triangle?
Yeah.
Yeah. What about 3, 4, and 5? Is 3 plus 4, is that greater than 5? Huh?
Yes.
You've been like on a roll with everything being right, but 3 plus 4 is not greater than 5?
Oh wait, yeah.
Yeah, 3 plus 4 is 7, so that's greater than 5, right? So I get a triangle. If I look at number 3, though, 3 plus 3 is what?
That's what I was looking at.
6, okay. So is 6 greater than the third side?
No.
No, so with those three segments, what you get is that picture where we're just rotating these third sides, or second and third sides, and they're never going to touch, right? There's always going to be a gap between them, all right? What if I go, the last example, 9, 11, and 20, will those work? No, because it has to be what?
Wait, no, because it's equal to 20.
It has to be greater than, okay? In this situation is where it's equal, right? So we're looking for greater. A second kind of type of question that they're going to ask for that kind of starts with that idea that they have to be greater. They're going to give you, let's say they give you two segments. They give you a segment of 4 and 7, and they ask you then, you're going to keep those two segments, 4 and 7, static. You're not going to change them. Okay. What is the potential limits of the length of the third side? How small can the third side be? Right here, we're seeing the third side cannot be 1, right?
It has to be 4 bigger.
Okay, careful. I make it 2, and they're not going to touch, right?
No.
Okay. But if I make it 3, do they touch?
Yeah.
Okay. So, but we know that gives me 7 is equal to 7, correct?
Yeah.
And we want 7, we want that sum to be greater than 7, right?
Yeah.
So 3 isn't my first value. 3 point, this is what you're saying?
Yeah.
The first, and this is where I want to make sure we all understand. The first number bigger than 3.
3.1.
3.1, 3.01, 3.0001. Those numbers are that bottom limit for that segment, okay? The thing that people are saying all day is that this segment here, the first segment length that could be would be 4. Okay, so I say it's got to be greater than 3. They say, well, the first one's 4. Well, the first integer that's greater than 3 is 4, but we're looking for the first number that's greater than 3, and that's 3.0000, however many zeros you want. If you don't include those, you're going to eliminate an infinite number of possible triangles. Okay? So, that being said, when they ask me for what that third side could be, I'm just going to call that third side S right now. S has to be greater than, in this case, 3, right? 3 was when they met right here. Okay? So then anything bigger than 3 will allow them to meet a little bit above that red line, kind of like that. Does that make sense?
Yeah.
Okay. How can I get 3 from these two given numbers, the blue one and the red one? How do I get 3 from that? Simply subtract them. So that's how you find your lower bound. You subtract the two given distances. Okay. Now they're going to ask you, well, what is the upper bound? What is, because if I make this thing 12, okay, and start to try to rotate these so they touch, we're going to kind of see that no matter how I rotate the blue one and the green one, they're never going to close each other off. They're never going to touch.
That's your 7 plus 4 isn't greater than 12.
Okay, good. Okay, so what is that? So 7 plus 4, the smallest two sides have to be bigger than this side, right? So what is that side going to have to be?
4. 12. Wait.
Careful. What's 7 plus 4?
11.
11. So doesn't this side over here have to be less than 11?
Yeah.
Because the smaller two sides have to add up to something bigger than this, right? So this side here has to be less than 11. 10.9, right?
Yeah.
10. 10.45, 10.9999, all those have to be the distances. So how can I get that from these two numbers? Add them. Okay? So 7 and 4 were your static numbers. You subtract them to get the lower bound. Okay? Subtract to get lower, sometimes called a bound, sometimes called a limit. Okay, so we subtract to set the lower bound. We add to set the upper bound.
Yeah.
Okay, so S would have to be less than 11, meaning that it could be 10.9999999 forever, right?
Yeah.
Now, if I do an inequality like that, a lot of times, if the number is greater than 3 and it's less than 11, the way we're going to write that is 3 is less than my third side is less than 11. And that tells me that that S, that value for my third side, my green side, has to fall between those two numbers. Anything else is going to not allow a triangle to be developed. Is that okay? So that's all inequalities for triangles, one triangle. Later on, maybe tomorrow, maybe Monday, we'll talk about inequalities in two triangles. Okay? But understanding this is a good start for being able to do that. Okay? There's a homework assignment in Math Excel.